I am Dr. Prince Sudherson, Associate Professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology. Today, I am going to discuss about the design of gearbox, which comes under the subject Design of Transmission System, subject code ME8651. Before we deal inside the subject, we can see about the course outcome. After successful completion of the course, the students should be able to analyze the concept of design in the flexible drive elements like belt, chain, and rope drives. The student should be able to develop a method of various types of gears with parallel axis. The student should be able to develop the method of various types of gears with inclination with angles. The student should be able to explain the techniques used in industrial design multi-speed gearbox application. The student should be able to categorize a suitable design for cam, clutches, and brakes for automatic application. Design of gearbox. Kinematic layout. A kinematic layout is a vectoral representation of gearbox describing the arrangement of gears. It provides information such as speed in each stage, the transmission ratio in each stage, the total number of speeds and its values. Calculation of number of gears to draw kinematic arrangement. Shaft 1, number of P1 gears. Shaft 2, number of P2 and P1 and P2 gears. Shaft 3, P2 and P3 gears. Shaft n, Pn plus 1 gears. Calculation of number of shaft to draw kinematic arrangement. Number of shaft equal to total number of stages plus 1. If 3 stages are there in a gearbox design, then the number of stages will be 3 plus 1 equal to 4 shafts. Draw kinematic arrangement for 12-speed gearbox. Case 1 is equal to 2 into 1 into 2 into 2 into 3 into 4. Calculation of the shaft to draw. Number of shaft equal to number of stages plus 1. Here 3 stages. First stage 2 into 1. Second stage 2 into 2. Third stage 3 into 4. So 3 stages. 3 plus 1. Calculation of number of gears to draw kinematic arrangement. Shaft 1 P1 gears. Shaft 2 P1 plus P2 gears. Shaft 3 P2 plus P3 gears. Shaft 1 having 2 gears. Shaft 2 P1 plus P2. Shaft 2 also 2 P1 plus P1 2. So 2 plus 2 4 gears. Shaft 3 P2 plus 3 P2 plus P3. Shaft 3 2 plus 3 5 gears. Total number of shaft 4. Total number of gears 14. These figures show the kinematic arrangement. Shaft 1 P1 gears, shaft 2 P2 gears, shaft 3 P3 gears, then shaft 4 output shaft. Case 2 Z equal to 2 into 1, 3 into 2, 2 into 6. Calculation of now number of the shaft to draw kinematic arrangement. Number of stages 3 plus 1 equal to 4. Shaft 1 P1 gears, shaft 2 P1 plus P2, shaft 3 P2 plus P3. Now shaft 1 having 2 gears, shaft 2 2 plus 3 5 gears, shaft 3 3 plus 2 5 gears. Total 14 gears. So this shaft having 2 gears, P1 equal to 2, P2 equal to 3, small gear, big gear, intermediate gear. Shaft 3 also having 3 gears, totally 14 gears. Ray diagram or speed diagram. The ray diagram is a graphical representation of the drive arrangement in general form. In other words, the ray diagram is a graphical representation of the structural formula as shown in figure. Here, 9-speed ray diagram is represented. Each vertical line shows the number of speed N1, N2, N3, N3, N4, N5, N6, N7, N8, N9. It provides the following data on the drive. The number of stages. A stage is a set of gear trains arranged in 2 consecutive shafts. The number of speed in each stage. The order of kinematic arrangements of stage, the specific value of all the transmission ratio in the drive, the total number of speeds available at the spindle. Procedure. In this diagram, shafts are shown by vertical and parallel lines. The speeds are plotted vertical and logarithmic scale with log as unit. Transmission engaged at defined speed of the driving and driven shafts are shown on the diagram by rays connecting the points on the shaft lines representing these speeds. Figure shows the ray diagram for a 9-speed gearbox having the structural formula is equal to 3 into 1 into 3 into 3. Basic rule for optimum gearbox design. The basic rules to be followed while designing the gearbox as follows. The transmission ratio, refer the figure. In other words, I minimum, so N max divided by N input equal to 1 by 4. I max equal to N max divided by N input equal to 2. For stable operation, the speed ratio at any stage should not be greater than 8. In all stages except in the first stage, N max, N input, N minimum. The sum of the teeth mating gears in a given stage must be same for same model in the sliding gearbox. The minimum number of teeth on smaller gear in drives should be greater than equal to 17. The minimum difference between the number of teeth on adjacent gear must be 4. The gearbox should be minimum possible size. Both radial as well as axial dimension should be as small as possible. Requirements of speed gearbox. It should provide the designed series of spindle speeds. It should transmit the required amount of power to the spindle. It should provide smooth silent operation of the transmission. It should have simple construction. The mechanism of speed gearbox should be easily accessible so that it is easier to carry out preventive maintenance. A gearbox is to be designed to provide 12 output speed running from 160 to 2000 rpm. The output speed of motor is 1600 rpm. Choosing the standard speed ratio, construct the speed diagram and kinematic arrangement. Given data, small n equal to n 12 speeds gearbox. So minimum speed is given 160 rpm. The maximum speed also given 2000 rpm. Then input speed also given 1600 rpm. To find, construct the speed diagram and the kinematic arrangement. Solution. Selection of spindle speed. We know that n max divided by n minimum n power 1 equal to 1.258. We can write 1.12 into 1.12 equal to 1.254. So 1.12 satisfy the requirement. Therefore, the spindle speed from R20 series skipping one speed are given by 160, 200, 250, 315, 400, 500, 630, 800, 1000, 1250, 1600 and 2000 rpm. Structural formula for 12 speed. The prepared structural formula 3 into 1 first stage, 2 into 3 second stage, 2 into 6 third stage. Speed diagram or ray diagram for procedure. Since there are 4 shafts, draw 4 vertical lines to represent shafts. Since there are 12 speeds, draw 12 horizontal equidistant line. From the structural formula, it is clear that there are stages in the third stage 2 and 6. 2 represent the number of speeds available in the stage and 6. The represent steps are intervals between the two speeds. Locate the first point A on the lower speed at 160 rpm. On the last shaft after 6 steps above, locate the second point P 630 rpm. These are the two output speeds. Locate the input speed at any point on the proceeding shaft, shaft 2, meeting the ratio requirements. We find out the input speed 400 rpm at point C. Satisfy the ratio requirements. In second stage, there are two speeds lowest in C, which is already located. Now located point D on the third shaft above point C. In the 3-step interval for these two output speed in the second stage. The output should be from shaft 2. We find the input speed 630 rpm at point E on shaft 2. Satisfy the ratio requirements. In the first stage, three speeds, lowest speed at E, which is already located. Now locate point F and G on the shaft 2 above point E in a single step interval. Input speed can be located anywhere on shaft 1 meeting the ratio requirements, but in this problem given that input speed is at 1600 rpm. In stage 2, we find input speed E gives the two output speed at C and D. Similarly, input speed at F and G should give you two output speed. This can be achieved by drawing lines parallel to EC and ED from points F and G as shown in figure. Now for stage 3, to get the output speed to all the input speed in shaft 3, draw lines parallel to CA and CB. Thus we have located all the input and the output speed. The complete ray diagram is shown in figure. This table shows the condition of satisfying identifying the input values. This is the ray diagram, stage 1, stage 2, stage 3. So stage 1, 3 into 1, 3 points, each point having one gap. Stage 2, 2 points, in between the points having 3 points, in between the points having 2 gap. Stage 1, stage 2 points, in between the points gap should be 6. These are the kinematic arrangement. Shaft 1, P1 3 gears, shaft 2, P2 2 gears, shaft 3 3 gears, shaft 4 output shaft. These are the systematic procedure for design the gearbox. References: this data is referred by these books. Machine Design, Volume 2, Design of Transmission System by Jalaluddin. Machine Design by R.S. Kurmi. Design of Transmission System by T.J. Prabhu. Design of Transmission System by V. Jayakumar. Thank you.